Are we good to go? Fantastic. Thank you very much, sir. Please give a round of applause to the technical team working very hard here. And with that, this hour goes downhill. Hello, welcome, everybody. There's a lot of available talks at this particular develop. Some of them even started on time. So I really appreciate that you came down to participate in this one. I'm Tommy. This is a beginner's guide to AI character design. So first of all, a small spoiler. This is actually more of a design talk than a coding talk, because I thought, well, it's the first talk after the keynote on the Tuesday. So I really apologize to whoever threw back like 4 coffees before this, like, I'm ready. And now it's like, it's not going to be like that at all. I do apologize. But what are we going to talk about today? So I really wanted to focus on the idea of, particularly for the roles of non-player characters, NPCs in video games, like helping you identify the roles of those characters in the context of the game that you're designing, and sort of what are techniques or tools or practices to apply based on those needs. Some of them are technical, some of them are more largely part of the overall production of your project, and things to think about as different departments work together to facilitate whatever it is you're trying to build. And also how to highlight, how to improve realism or enhanced features. And quite often we're doing that without actually making the system smarter. We're just finding ways to obfuscate how dumb it really is. So a little bit about me and how I go about doing this sort of thing outside of the confines of a 45-minute talk window here in sunny Brighton is that to the wider world, I'm a YouTuber, which is a sentence that doesn't get any less weird the more times I say it. And I've been saying it now for a lot longer than I would care to admit. So I've actually come from a lapsed career in academia. There was also previously a few years I worked in investment banking as a software engineer, but we're not going to get into that. And one of the things I started doing as a university lecturer was I became really invested in communicating to people a lot of the technical intricacies of games in a variety of different forms. I have a PhD in the background of artificial intelligence for games, and I made a YouTube channel called AI in Games. Marketing isn't my strong suit. And so 3 things I really like to focus on is we will look at actually big AAA titles or even indie games and explain how they work, even if you don't have a background in the field. We also look at sort of the big things that are happening in AI research that is particularly invested in games, and why is that important, why is that relevant, and how does it work? And also kind of introducing fundamentals, which is often useful for students. But the truth is, I actually have spent the last 3 to 5 years working in the industry, and I do a variety of different things, whether I consult for companies big and small to get them to understand the tools or potential pipelines that they could be introducing. This whole deep learning thing is very popular at the moment, and so trying to communicate what value there is to that to different stakeholders is often a challenge. I do a lot of media and communication projects, but particularly for the context of this talk, I'm actually quite involved in a number of games, either as a programmer or often operating as a sort of tech/design consultant. So, right, let's get into this. I kind of broke this talk down into 4 key areas. Purpose and function, we're going to talk about design develop practices and the importance of smoke and mirrors. And then one of the things that I really focused on during my time, particularly working on some of the games mentioned earlier and some of the games I can't talk about, on what I consider to be the axes of consistency. So, quick thing. We're talking about game AI here. So you're hearing a lot about artificial intelligence in the wider media, and then silly stories about Google inventing a chatbot that's sentient, which is, I don't know if I'm allowed to say this, it developed bullshit. Google the Eliza effect. Stupid people have been making the same stupid assumptions for 60 years. But anyway, but we're particularly talking about game AI. And this is a particular set of tools and solutions that very much deal with games design problems. We're really interested in this idea of experience generation. And so we're catering to the kind of multidisciplinary nature of the field, of the industry. So quite often you have different tools that are designed to facilitate the aspects of behavioral design. And then that has to interface and work with other parts of your production team so that you can then get the yield, the output that you really want. And a key thing that I always kind of try to hammer home is that a lot of great AI is really just good AI with very clever framing. So let's talk roles, purpose, function, and what have you. So one of the things I really like to do when we're thinking about different systems in our games is understanding the roles of the AI in the context of that game. And so it could be that you have, I've actually come up with just 6 here that I think are relevant. You have opponents. These are typically systems that are trying to win the game. quite often they don't have an avatar, so I wouldn't really consider them to be a non-player character, although actually probably fighting games is the closest equivalent you can think of, because that is a zero-sum game in which there is one winner, one loser, but you can clearly see the other character in that instance. But opponents are typically used for things like strategy games. This was meant to be videos. They're not moving. It's fine. We'll wing it. Dungeon Masters is actually more akin to the notion of directors that we see in games like Left 4 Dead and pretty much every open world game that now exists. But predominantly what I'm interested in are the four on the right-hand side. So we have the notion of an adversary. An adversary is a non-player character, much like the opponent, but its goals are not diametrically opposed to the player's intent. Good example of this is, of course, the Xenomorph and Alien Isolation, and actually a lot of other horror games of that ilk. Mr. X from the Resident Evil 2 remake, and the original, of course, as well as the Nemesis from Resident Evil 3. Because these characters, they're designed to block your progress and to prevent you from completing your next task. But fundamentally, they're going about their own objective. And so they're there as largely a massive hindrance. You'll also have challenges, and these are non-player characters that are there to just block you or introduce a puzzle that you have to work around. In the context of that video, it was actually just zombies from the Resident Evil 2 remake. I was playing a lot of the Resident Evil 2 remake when I was writing this. So... supporting the player. So this is usually a non-player character that is designed to help guide the player through the world. And I picked Alex Vance because there's a small subset of the internet that will get really annoyed if I don't pick Alex Vance for this particular example. I would prefer to actually say Elizabeth Comstock from BioShock Infinite or Ellie from The Last of Us, because I think they're much more technically interesting projects. But also the idea of supporting the fiction. So we want players to feel engrossed in this world. We want them to feel engaged in this environment. And you want to make that story that you're trying to create feel authentic within some defined notion of realism. Notice that we're always aiming for kind of heightened realism because this is a video game, unless you're Rockstar, maybe, I guess. But by and large, we're trying to just kind of support the infrastructure of the narrative. And so I picked Hitman because I think that's a really, really good example, because often as Agent 47, you are going into highly densely populated areas trying to complete a task. And these people all have their own aspirations or goals or even just things that they're doing. And then you have to be able to operate within that. Now, at the end of the day, and this is kind of an important thing, I think, particularly when I'm looking at this sort of stuff, is embracing the notion of theater. So the more I've worked on this sort of stuff, the more I've really came to position my perspective on this, is that really what we're actually doing is we're actually participating in a theatrical production. There's just a lot more technical overheads. And I think the audience is a little more toxic. I'm not sure. Any theater geeks in the room could maybe prove otherwise. And so one of the things I think is really important is to understand that the player is the audience in a theatrical production. But of course, this introduces a whole number of problems, because if the player is the audience, imagine you are playing a video game right now of a conference presentation. It's not going to get high Metacritic scores, probably, but bear with me. There are certain concessions of this theatrical production that you expect. So first of all, we've got to think about blocking. Where is the player and where are all the characters in context of that? And subsequently, how does that inform the behaviors and all the other systems that are running around it? We want the player to see the production in its best light. And so typically, if you think about this, whenever we're doing a presentation, you're all sitting facing me, and I'm really confined to this area, but I really love, you'll have noticed, I really love just having the freedom. But I'm not allowed to do this, you know? I really apologize to the poor lady who's recording me right now, because now I'm breaking all this, because there's a whole bunch of people at the front going, this is really inappropriate. I can't see what he's doing. I'm so sorry. But so already we're breaking the rules here. So from a technical perspective, we always have to make sure that the player can see the world in its best light, and also that the game world is accommodating to that and saying, where's the player going? Do we need to turn systems off? Do we need to turn systems on? It's a bit of a challenge. But also on top of that, we have certain expectations of this framework that currently exists. So thinking of yourself as the audience, imagine you're all non-player characters in a game. We have certain rules that we would expect you all to adhere to for the purposes of this presentation. you're kind of all sitting, looking at me in the general direction. Some of you might look at your phone or might just be like on Twitter, like, who the fuck is this? Come on, a load of nonsense. But that's fine. That's within the defined parameters. So we maybe expect you to do A, B, C. Some of you are going to do actions D, E, and F. But say, for example, gentleman in the middle there just stands up and goes, I've had enough of this, and storms out the room. That's not really in keeping in the, please don't do that. That's really going to damage my ego. But that's really going to break the rules that we've established of what this particular occasion is about. And in the context of the game, you might want that. You might want a game that you're just like, you know what, it'd be great if just one person has a fit, throws their chair at me. So it's all about, we assign an etiquette within the system of what we want to happen. And then maybe we want to have some surprise. We maybe want to have actions that occur with a very low probability, but are all within that framework, that framing. And it's also important to then recognize, what does the character do? So we talked about blocking already, that if I move around the room, then we're, oh, well, that character maybe needs to be a little bit more active because it's closer, it's more foregrounded to the player than another character. By the way, there was a whole slide of videos that goes with this, and this is why I'm being very dramatic at the moment. Thank God for water. But what if I start just, messing with the system a little bit? So unfortunately, I know Mark already, but if I just start giving Mark a hard time, within some defined, look, actually, you did a great job there. You already did at least the basic reaction of, oh God, he's hitting me. But we also are kind of hoping that maybe he's going to react to this very badly. Please don't. I'll buy you a drink later. And that fundamentally, we want to see how far the player can push that system before it begins to break. And funnily enough, when we have a very good understanding of what that ecosystem is, when it does break, it's actually quite apparent. You can tell the difference between an emergent property within that system versus a bug quite often. And heaven forbid anybody on Twitch finds it, because then they're just going to keep doing the same things over and over and over again. So this doesn't work. I was going to say this is when it now works. And then I'm like, oh, anyway, right. So thinking a lot about what are the individual actions that you really want a character to do, and how do we expect them to be executed? And subsequently, also, you're looking at it from a design perspective of how am I going to put all this together and what things are meaningful to me as the designer? I feel like it's a challenge that I need to drink every bottle of water on that table by the end of the presentation. I do apologize for anyone who watches this in a recording like a year from now. You're not really getting the real meat of this presentation. So there's two ways to really think about this, is that quite often we think about it from a bottom-up approach, where you start establishing all the individual actions that you want a character to have, and then enable a way to glue them all together in the system in ways that we think are meaningful. So, for example, if you have a character that's a guard in a stealth game, for example, you will think, okay, they probably need to have an idol where they maybe stand about and have a little look around and see what's going on. Oh, thank you so much, sir. This is why the black t-shirt, you can't see the sweat down the back. But also that guard will then begin to patrol. So we'll say, okay, well, a patrol means that we need to have an interface with our navigation system, have them move to fixed points in the world, and then they'll maybe do an idle again. And but then, of course, we see a player, we see who's maybe antagonistic in this context. They detect them, they maybe try and rush them down, attack them, etc. So we're thinking about individual actions that can then be glued together in the context in which they might happen. A very common example for that is use of things like finite state machines, where we're simply saying that each state represents a higher level behavioral function, such as patrolling, idling, searching an area, for example, attacking the player if we've seen them. And then we're figuring out the transitions between them. We're going to draw lines between each of those circles and figure out how they click together. Now, this works surprisingly quite well. The problem with this is it doesn't really scale particularly well, because if you have more and more individual states, you then have to think about how do they all come together? What are these different factors that can happen? And this, we're going to talk about this a little bit later on in this presentation, provided the laptop doesn't blow up, that you're going to have a number of compounding factors happening at once, but you're also going to have a number of factors that occur within a very protracted time frame. And suddenly, what is relevant in those transitions might change. You might think, in this moment, this transition is relevant, but actually in half a second later, it would be more useful if I transition into another state entirely. So there are ways to kind of mitigate this a little in this kind of technical side. quite often, these are quite old, outdated approaches to some extent. Finite state machines have been around pretty much since the 90s, and even hierarchical finite state machines where we're saying, well, this is maybe the searching for the player segment, and it can only move between certain states, but there's only some transitions it can come out of. And there's even other approaches, which I don't cover here, such as utility AI, where we can start trying to compute, the value or need of a particular action as a function, and say, okay, well, actually the need for health, for example, scales up in such a way that once the health is getting down to a certain level, it's now incredibly critical. And we can kind of grade the relevance of a particular action from one another in a mathematical context. Another approach to this, which is actually much more, has become more popular in the last 15 years, is the idea of planning. And this really gets to one of the points I make here of the lack of authorial control and oversight. So planning techniques, again, to kind of derive from other areas of AI, is the idea that we start having rules as to whether certain actions can be executed, and there's an encoding in there that you can write in human language to say, for example, if I want to attack the player, I need to make sure that, my target isn't dead and I have a loaded weapon. Because if the target's dead, why am I attacking it? That makes no sense. So you're kind of encoding some sort of logic into that system, which gives you some level of understanding. Now, this was largely popularized by games like Fear 15 years ago, which if you then go and Google top 10 games with good AI, it still appears usually in the top one. But there's a fundamental problem with it. And actually, one of the reasons, and this isn't to say that Fear is not a bad game, Fear is a great game. There's a fundamental problem with using this approach in that you're actually at the mercy of the system to figure out how these actions glue together. So here, we've got a number of different actions it uses. It can attack the player, it can load a weapon, it can draw a weapon. But the way that this works is it starts at an initial state, say, I am under threat, I need to find a way to remove the threat, and it figures out a series of actions. Well, I should attack the player, but my gun isn't loaded because the precondition is false. So I should get my gun out, load the gun, then attack the player. That has satisfied my immediate task of minimizing the threat being placed against me. But there's a search algorithm running underneath that goes, right, well, you can't apply that action because the precondition isn't there. So maybe, can we apply this action right now? Oh yeah, because the preconditions are valid. Does that work towards the goal? Maybe. Well, let's just find out and see what happens. And so what actually happens in those games is that it comes up with a plan of execution that's several actions long. But the reason it works is actually in Fear, most of the plans are only 2 to 3 actions in length. And most of them are run over here and shoot something, which in the context of a first-person shooter, that's great, because that's what you want. Oh God, they're finished already? So this is, you're removing the authorial control of the designer to say, no, it would be really good if that action goes next to that action and then we do this. And so this is usually where we get into notions of top-down design, where we start thinking abstractly and then we figure out the details. And this is often more amenable to a lot of designers' needs, because you often think, well, I want a character that will ambush the player. Cool, because we understand at a high level in English what we mean when you say, I want that character to ambush that player. What does that mean in the context of the game? Well, I'm going to need to get it to move. It's going to have to find a good point to ambush from. So we have to calculate spatial information about the available environment. This is a good area to try and path towards. Can it path towards it? Yes. Okay, then we move over. Once it's maybe hiding behind cover for long enough, it will then pop out and take a shot at the player. Great. So you start with this approach of just burrowing down into something that's much more meaningful, and it's less emergent, but it's ultimately more dependable. The only problem then is it can be a little bit harder to appear spontaneous or dynamic, and quite often the solution to that is you inject an override. You tell it to drop whatever it's doing because something more important has just occurred. This actually dates all the way back to the likes of Halo 2. And typically, anybody who knows their way around Unreal Engine will have recognized that behavior tree has been on the slide for a little while now. And of course, again, behavior trees are really useful for this, or directed acyclic graphs, if you want to get all computer science on you, because we're starting at a higher level, and then we're breaking down key bits of logic about what we want that character to do. Another alternative approach, I'm not going to spend too much on behavior trees, because if you spend a lot of time in Unreal, you'll probably be familiar with them to some extent, is actually what's known as hierarchical task network planning. So this comes from the same corner of AI research as the planning system we saw in the previous slides, particularly around Fear, where what we're doing is we are decomposing a complex task through task networks. And task networks allow you to solve different subsections of a larger task, but often a task network is comprised of one or more individual actions or other task networks. So you can say, right, I want to recursively iterate down and break this task down into more and more meaningful individual atoms. And this originally was, I think, probably the first studio that's actually implemented this is Guerrilla Games. It was first used in Killzone 3, and it's subsequently been used in everything else they have done since. I did a video on the AI of Horizon. I did 2 videos on the AI of Horizon Zero Dawn, which are worth checking out on that. I also looked particularly at the work by High Moon Studios on Transformers Fall of Cybertron many years ago, because they originally used goal-oriented action planning and transitioned over to HTN because they were finding it difficult for the system to find good actions quickly. Here, you're actually having a lot more control over what it's doing. And so it says in order for it to attack a particular target, it has to make sure it has the firearm and it has the ammo. But if those two things aren't satisfied, here's the subtask networks it needs to execute in order to satisfy those individual conditions. And then once they're right, just go back to the start and try again. And it will continually iterate and finish all those individual subtasks to get to where it needs to go. And so this is actually a particular UE4 plugin that's available. I would also highly recommend Fluid HTN for Unity developers, which is a completely open source project developed by Paul Treffel. Right, where am I going next? Yes. I think it's also perfectly valid to try and mix your methods. Quite often you see a lot of games will find that you want to have a lot of authorial control on the high level behavior of a character. So, right, I really want to make sure that the higher levels of what it does, it's going to chase, it's going to patrol, it's going to wander around, it's going to do this in like a stealth game, for example. But then you want a lot more minutiae and like kind of fidelity in the actual execution of those high level behaviors. And so quite often you'll see someone use a finite state machine to control the top highest level of the action selection process, and then the actual minutiae of its execution in the game world is handled by a behavior tree, although use other mechanisms to kind of glue all this together. In fact, Final Fantasy 15 is a good example of this. I believe all their behavior trees are actually just part of a larger state machine, where for both for the enemies as well as the character companions. I still haven't done a video on that, sorry. You'll have noticed, actually, I haven't mentioned that dreaded phrase machine learning much today. Now, there's a lot of value in machine learning, particularly, but in the context of a lot of character design, it's actually a bit of a hindrance, because a lot of approaches training sort of reinforcement learning policies or neural networks is it becomes a bit of a black box. You establish the input parameters you want and the output systems that you would, or the output behaviors you would like to exhibit, and then it's kind of a bit of a dark art in training the system. I appreciate for anyone who's sitting here who actually knows much about machine learning is like, lies! Yeah, but it is really. So quite often you'll find that a machine learning system is very useful in individual parts of this process. I actually think signal processing for different information and how to react to it is probably one of the most meaningful and useful machine learning applications here. But critically, it robs designers of a lot of authorial control. And so that's why I'm generally a bit reluctant to kind of advocate for it. And certainly talking to a lot of designers, they're kind of in the same boat. Right. Smoke and mirrors. Here we go. Here's the fun bit. How are we doing? We're actually doing all right for time. I might melt down and turn into a puddle by the end of it, but, you know, be sure to vote for this talk at the end in whatever surveys they give you. Right, so smoke and mirrors. One of the really important things to take away from this is you could spend hours on this. You could spend weeks iterating on your toolchain and building these really nice, intelligent processing systems for figuring out this is what the character should do in this particular context. Problem with that is, how does the player know any of that? So if I was to ask you right now, what am I thinking? I mean, that's a given. Hang on, what type of hot? Right. So you could spend all this time with an AI iterating, it comes up with a decision, and then you go, but what's it really thinking and what's it doing? Because this NPC is just stood in a corner. And then it chases you. I'm like, Jesus Christ, what's it doing? So we really need to figure out how other gameplay systems can communicate this. Whether it's through animation, whether we're using visual effects, whether it's UI, sound design, music, there are so many small ways you can tell a player something in a way that communicates it. And I deliberately used Metal Gear Solid for this particular example because, well, that exclamation point has probably been more meaningful in the context of game design than anything else in the last 20 years. You all know, you can hear it, right? Whole bunch of you are going, yeah, I know what that sounds like. Right, you do, because it's encoded in your brain. It's a very simple process. Character turns around, animations change, big floppy exclamation mark on the top of his head that goes, yo, what's this? And then the UI changes, the music changes, the camera changes, and the player goes, oh, I think I might be in trouble. I should act at this point as he's beating the living daylights out of you. So yeah, it's all these different systems coming together. That's the wrong, no, that's fine. I looked at that, panicked, because this is not going through this anymore. So here's a bunch of really simple tricks that add a lot of impact. If you have multiple characters, or even one character trying to pay attention to the player or other gameplay systems, and they need to have meaningful, useful information, just have one character process it and then tell everybody else. Even things like, where is the player? Just ask the player to drop breadcrumbs of its location in the game world periodically. If you don't want to have it too accurate, have that information updated on a certain number of game ticks and increase the number of game ticks once the player hasn't been seen for a certain number of seconds, and then eventually just stop giving that piece of information. So it gives the idea that it's kind of following the trajectory of the player, and then it loses them. Recording and regurgitating player activity is one of my favorite things. If you saw the player do something, respond to it in the simplest of ways. Really straightforward example is if you're playing a first-person shooter, you throw a grenade at a soldier, and the soldier goes, grenade! Well done. You've successfully communicated to the player that they have seen that you threw a grenade at them. Even if all you did was went, hang on, they pressed the grenade button. Is there a character in proximity? Yes, fire that line of dialogue. Really simple. One of my favorites in recent years was I was playing the PS4 Spider-Man game, and it's the social media feed of the things that are happening, and people are going, well, Spider-Man came by and he beat up those two guys over there. And to be fair, most of it's rubbish, but it kind of correlates with the things that you're doing in the game, and you're like, that was me. I'm Spider-Man. That's great. It's so dumb, but it gives you that little moment of value. And then I remember I'm spending too much time looking at social media, even in video games. Express with exuberance. Any animation you've got, dial it up a little bit more. I often highlight the Batman Arkham games are a great example of this, because it also combines a lot of exuberance with barks and clip dialogue. So, you know, if a character gets knocked down and beaten up and someone comes over and they find the body and they go, hey guys, over here! Throws his back out doing it. And of course, as the Batman, you're up there on the gargoyle, like, that's right. But it clearly communicates once again what it was meant to be talking about. Barks and clip dialogue, having little lines of dialogue that they shout at each other. If they're going to flank you, have one say, flank him! And then you go, oh, they're trying to flank me. That's so clever. Oh yeah, and repeat that if it's not clear that they heard it. Don't collaborate, deliberate. This is a very important one. So coming back to the flanking, games like Fear, they quite often achieve collaboration, not by having the two characters know that they exist. Don't do that. Multi-agent decision-making systems are an absolute nightmare. Sorry, that's the formal academic term for it. What I'm saying is don't have two AI that know what each other's doing, because that's just a headache. Have another system that goes, right, I would really like a collaborative opportunity to happen here. Well, you two guys are next to each other. And that gal over there, she looks great. Okay, cool. Could you tell them to do this? And then you two are going to do these particular actions with a small time delay. And so you have one character then go, flank him! And the other character then goes, oh. That was a flanking maneuver, by the way. And the whole time you're like, oh my God, they're talking to each other. And it's all because, could you just say that line of dialogue? Why? Just do it. Okay. Flank him. Now what? Well, no, go do whatever you were going to do. Okay, thanks. A weird one. This was actually a player study that was conducted by Bungie many, many moons ago. One of the easiest ways to communicate a system is smarter than it looks. Give it more health points. Because it allows... I don't agree with this necessarily. I saw a couple of shakes in the room like, no. But there's the idea is that it allows you to see more of the behavior of the system. I think, take from that what you want. Also, this is going to come back in a few slides. Establish what the rules are of your game and then start figuring out how to break them. And this can often mean introducing behaviors to a character later on that changes how the player engages with that experience, but you need to give them enough time to have figured out the basics before you start trying to break the rules. Right, nearly there. Oh, good, we're good for now. Okay, what I think, I have this thing that I think about a lot is sort of our 4 axes of consistency. 4 different elements of a character's design that are really important in communicating to the player that they're much more intelligent than they really are. Also, it allows you to address and identify issues you're going to have early on. So sensory, this is the sense that the senses of a character rather have to be consistent. We should be able to infer from them what they're actually going to do based on the player's internal interpretation of how those sensory systems operate. Knowledge consistency, which is the idea of information that's stored. It should be accurate, meaningful, and timely, because it's going to influence the actions that it then executes. Temporal consistency, which is understanding that all it takes for a character to look intelligent is for it to do 2 or 3 things within a very short window that don't look dumb. And also subsequently, all it takes is for one dumb action to break it. And lastly, contextual consistency, which is the idea that a character should act in accordance with the context of the world. And that allows us to catch a lot of potential problems that will arise. So, sensory consistency, when we have a lot of sensory systems, if we use vision cones or any sort of audio perception for a character, it should make sense to the player to some degree. You should be able to get a sense of consistent feedback as to what it's doing. If a character can spot you standing in a corridor, odds are if I put the same situation together, it should be able to recognize me every time. If I start introducing things that might influence that, such as the light levels, such as obstacles that can block their vision, there's an expectation that that is also going to influence how they detect me. And then again, if I'm coming up with specific scenarios to test that, it should be consistent. Because essentially this does 2 things. One, it gives the player an understanding of how a sensory system works. They never acutely understand it exactly, but they'll have a very rough approximation of it. And even if you're using, you look at things like Far Cry, which has it in the UI that they actually give the vision cone detection. So you can see, oh, I'm being spotted, and oh, I was spotted. Over time, they're able to understand that system well enough that they can game it and they can operate within those parameters. It also removes the notion of omniscience. If you can clearly define to a point that the player begins to reverse engineer how that sensory system works, when they're spotted, the player should actually go, well, I was spotted because it saw me and I know what those rules are, so it makes sense that it saw me. And it shouldn't be a case that the player feels robbed, that, oh, I shouldn't have been spotted there. Sometimes they'll do that because they moan, it's gamers. But by and large, we want to remove that from it. And particularly having a data-driven approach where you can then tweak the parameters of those systems and iterate and test on it is really valuable. Having tools to facilitate all of this is incredibly useful. It's a point I make on the last slide, but it's kind of persistent throughout the entirety of this talk. Contextual consistency? Oh no, knowledge consistency, sorry. Knowledge consistency, really, we just don't want non-player characters to have out-of-date information. To a certain degree, maybe you want to have them know where you were 2 seconds ago rather than 10 minutes ago, because then you're going to see a behavior that perhaps makes sense if it saw you 10 seconds ago, so it's trying to find you, versus, well, it's looking where I was 2 minutes ago. That makes no sense. It needs to make sense in where we are right now. And also, I think fundamentally, we don't want characters continually calculating information, because that's just going to impact, our CPU budget and ultimately impact how much resource the AI has to play with. Don't waste time computing realistic information. See if you can actually reverse engineer it from other sources much faster. It'll allow you to achieve your goals much more amicably, and then figure out how to fudge it or add noise to it. I think is more appropriate than going the other way around. That's the wrong presentation I clicked on. Contextual consistency, this is probably one of my most important ones. Does it make sense for a character to make that action in this situation? And what are all the different things that your character should respond to? So in my case right now, as somebody standing on top of the stage, someone's looking a bit sweltered, they're checking their phone, maybe they're yawning or whatever. I shouldn't react to that too drastically at the moment. come and find you in 10 minutes though. No, I'm kidding. So it's important that those things aren't relevant to me right now, but certainly those particular behaviors, I could react to them in a different way, in a different context outside of this one. One of the things I spent a lot of time doing on some projects is this notion of a reaction matrix. What are all the individual things that our character could potentially respond to? And what are all the potential events that run in the game world? And then or even what are all the different behavioral things that the character can be doing? So when that event runs in that context, should the character respond to it, yes or no? And trying to have an understanding of that earlier on in the process is much more valuable, because otherwise what starts happening is you start ending up like months down the line as you're testing, it's going, oh, it's reacting to this thing in this very particular context. And why is that? And it's like, well, because we never actually thought that far ahead that, oh, that event could trigger something in that behavior at that time. And so trying to foresee those issues, I think, is really useful. So, like I say, a gun, we don't want a guard to run towards a loud noise. We might want them to run towards a loud noise, but in the middle of combat, for example, it's not going to run towards every loud noise, because that's the worst soldier in the world. It's just rabbit in headlights. So yeah, thinking that through. I also spent a lot of time, particularly actually on Espire, working with the narrative design team, because we have a lot of different actions that characters can do that counteract the player's ability. And it's like, when should those be made available? And when do we start creating tutorials that communicate how those systems work to the player? So maybe we're a few encounters in, we're feeling confident that the player can use this ability. Maybe now we can introduce that character in this encounter, and that allows us to run a tutorial that highlights how this new ability they've got can counteract it. Or even something simple like Alien Isolation deliberately has the system unlock behavior subtrees the longer you play it and after you complete certain objectives, or actually avoid the alien in certain ways, because it gives the player the illusion that it's learning when it's not. Just the Boolean went, right, true, good, this whole new available suite in the behavior tree is available, but it's helping show this gradual improvement of the systems and their ability. Lastly, this is a small one, which I could talk 20 minutes about, is the notion of inversion of control. Don't tell every single AI character how to sit down. Have the chair tell the AI character how it should sit down. Encode the logic of how the chair works in the chair, not in the character. Because otherwise, every behavior subtree has now got, is it that type of chair? No. Is it that type of chair? No. What about that type of chair? What about this one? Instead, you come up to the chair, and the chair goes, all right, buddy, you need to stand here. Turn around. Yep. Use this animation. Okay, cool. Well done. You sat down. I'm like, great. How do I get up? Play this animation. And you're good. Right, on you go. Right. Well, thank you very much. That's wonderful. BioShock Infinite did a really great job of that, particularly with Elizabeth. Temporal consistency, really, if you have multiple signals that happen within a very short period, which one is more important? And what is their temporal decay? So if it's, explosion, gunfire, rabid monkeys, which one is the one I really should be focused on? It's like, well, that was an explosion. That was gunfire, but the gunfire's nowhere near. Oh, the rabid monkey's right there. But that's the most important thing right there, because there's a rabid monkey in my face. However, if it was explosion in the distance, gunfire because someone over there's got an assault rifle, and the rabid monkeys, I can kind of hear them, but I can't really see them. Well, clearly the gunfire was more relevant there. And so that becomes a system of not just understanding what each of those things are, but in the context of the behavior of that character, and all that you could grade each stimulus. It's like, okay, well, can I see the thing that caused the stimulus? Is it close to me? What tier of importance does that stimulus have? And you can start to build a priority queue of different things you might want to look at, but also all of them decay, because eventually it will forget about them. Because you don't want it to like, right, stupid rabid monkeys, there we go. And then 20 minutes later, explosion, because that didn't make sense. And that's us. I think we're just about done here. Oh yeah, and that last thing, like I say, all it takes is for you to do 2 or 3 actions next to each other that make sense, and the player goes, look how smart that thing is. And then it falls over, and you go, oh man, that's bugged, and it's broken, and it's dumb. So with figuring out that consistency, I genuinely think this is why games like Fear actually planned very short plan lengths, because what it did was subsequently very effective for what it was requiring. So, bringing it all to an end, so we can all get outside and jump in the nearest ocean, I guess. Try and identify what the roles are of your characters in your games. And this will help influence your design approach ultimately. And what information is important to them and how best to communicate their function within the game to the player as they're experiencing it. Kind of unspoken element is a lot of these aspects. Figure out tools within your own pipeline that will help facilitate a lot of this. I often think of things like having, sensor systems and outputs being able to be quickly debugged and tweaked, being able to hard trigger an AI transition in engine, and doing things like using the Unreal Visual Debugger to actually see the actual Markov chain of actions. Like, how did that character end up doing that thing at that point? Here's the history of its thought process for the last 2 minutes. And you can kind of see that critical point where it's like, and it was at this moment, he made a mistake. And you can begin to infer back why that could have happened at that point. And yeah, figure out when it's appropriate to fake it and when you really need to maybe spend a little bit more time on the engineering side of the project. Some additional resources. Yeah, we're very tight on time, but I would highly recommend, the AI Modern Approach, which is more of a scholarly book. AI for Games by Ian Millington and Artificial Intelligence in Games by Tougelius and Yannakakis deal with more industry and then kind of upcoming academic kind of AI research that could impact games. The Game AI Pro series edited, which is now also freely available online, edited by Steve Rabin, who I work with over at GDC, is fantastic, well worth it. Get all the free stuff out of the GDC Vault and the AI Summit where you can. Minor disclosure, I am on the advisory board for that. We do some good talks. Well, I don't do any of them, but we just say, hey, could you come and do that? Also, like and subscribe, yeah? That'd be great. A few bits of additional viewing. I'd highly recommend, if you're interested from a more technical perspective, check out Sandy and Rob's talk. They're from Kythera AI. They gave a more technical talk on what's next for game AI NPC systems. If you're more interested in sort of machine learning and overall game development production pipelines, my talk from 2 years ago. And also, if you're still kind of a bit terrified of machine learning, Andrew Webb's talk that was also delivered that year is a really nice kind of opening insight into that. And I think we're done. Thank you very much. We did it.